Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, New St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, Crossing New Frontiers to Conquer Today's Challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, New St. Augustine.
My system of coupled, nonlinear, time-dependent, and state-of-the-art partial differential equations of modern mathematics, called Philip Emeagwali's equations, were developed only for research computational mathematicians. I told mathematicians attending the 1991 International Congress of Industrial and Applied Mathematics the following: as a research mathematician and as a research physicist, I always knew the fact that the scientific discoverer discovered a truth, whereas the inventor of a partial differential equation formulated possibilities. To invent a new supercomputer is to make the impossible to compute possible to compute. To discover is to see something that was previously unseen. A scientist on a research for new knowledge is a truth seeker that is seeking new truths. A supercomputer scientist on a research for a faster supercomputer is seeking a new supercomputer and is seeking new computer. The discoverer becomes the first truth seeker. The scientific researcher is on her hero's quest for the previously unseen truth. Our never-ending quest for the fastest possible supercomputer has become our journey to the frontier of human knowledge. That never-ending quest has become a self-directed evolution in which we are both the creator and the created. That journey to the end of knowledge will force our post-human descendants of a million to know the answer to the larger question of who we are and where do we want to go. Back in June 1990, Steve Jobs was looking for a new direction. Steve Jobs was intrigued by my experimental discovery of how and why parallel processing across a new global network of 65,536 processors, or across a new internet, reduced 65,536 days or 180 years of time to solution on only one processor that is not a member of an ensemble of processors, to just 1 day of time to solution across a new internet that is a new global network of 65,536 commodity off-the-shelf processors. I visualized my new internet as encircling a globe or a hyperglobe in hyperspace. I visualized my new internet as a new global network of 64 binary thousand processors that were equal distances apart and on the surface of a hyperglobe within a 16-dimensional hyperspace. Leapfrogging upwards from the third dimension in space into the 16th dimension in hyperspace leaves the non-mathematician to wonder, where did the extra 13 dimensions come from or go to? On my motherboard, the extra 13 orthogonal dimensions were compressed into the depth, height, and width directions. That invention is my contribution to the development of the first internet that emulated the fastest supercomputer and that could be harnessed to massively parallel process across a new ensemble of 65,536 processors. My invention of the massively parallel processing supercomputer that occurred on the 4th of July 1989 changed the way we think about the new supercomputer that is the new fastest computer that should become the computer of tomorrow. My invention of the massively parallel processing supercomputer opened the door for the biggest paradigm shift in extreme scale computational physics and opened our eyes to enable us to see modern physics in a different way and to understand the modern scientific method as referring to computational science as the third science that complements theory and experiment. That invention of the massively parallel processing supercomputer garnered international headlines, and I, the storyteller, became the story and the subject of school reports titled "The Contributions of Philip Emeagwali to the Development of the Computer." The uncharted fields of knowledge is the new land to be explored and colonized. That new land is explored the way Bongo Park explored the River Niger of West Africa. The exploration of Mungo Park opened the door for Great Britain to colonize my country of birth, Nigeria. I am the Mungo Park of the supercomputer world that was searching for the fastest computation ever. I was searching for the new supercomputer that computes in parallel instead of in sequence. In the 21st century, Africa must cross new frontiers of technological knowledge to conquer today's challenges and alleviate poverty. On the 4th of July, 1989, in Los Alamos, New Mexico, United States, I experimentally discovered the massively parallel processing supercomputer. Since my experimental confirmation that the massively parallel processing supercomputer can be used to make the impossible to solve possible to solve, I am often asked to explain how parallel processing benefits you. That's like asking, what will the world be like without parallel processing? A world without parallel processing is a world in which 99 of the 100 processors inside your computer is turned off and you are computing at 1% of your computer capacity and perhaps achieving only 1% productivity level. A new supercomputer without parallel processing is reduced to the stature of an ordinary computer. A new supercomputer that is not parallel processing is like Lagos, Nigeria, with only one street light on. The fastest supercomputer costs the budget of a small nation, and it is purchased because the fastest supercomputer gives meaning to life, and because the fastest supercomputer makes the world a better place, and because the fastest supercomputer makes humanity more knowledgeable, and because the fastest supercomputer of today will become the computer of tomorrow. The scalar processing supercomputer helped the first man that traveled to the moon to return safely from the moon. The vector processing supercomputer helped man fly faster and helped the first woman that traveled into outer space to return safely from outer space. The parallel processing supercomputer will help the first humans that will travel to the planet Mars to return safely from the planet Mars. And faster supercomputers is where science fiction will become non-fiction. The fastest supercomputer is where humanity's future takes shape. Parallel processing has taken the computer into a new era.
Insightful and brilliant lecture.